Yeah. Great. So Rachel, can you go ahead and send a longitudinal continuous wave to Brian? Yeah, so Rachel's moving her hand forward and backward because for longitudinal, the pieces of the medium have to move the same way as the energy. And then Rachel, go ahead and send transverse, whatever, continuous is fine. Yeah, so she's moving her hand side to side. Perfect. So Brian, can you put that on the little stand in that box and then just lay it down? So we have about 4 more minutes. So I think a reasonable goal will be for us to just take a look at some of the wave features associated with transverse waves. And just one other kind of slight correction before we move on. Right, it's longitudinal, and then it's transverse. Okay, so I think I heard some mixing. I think I heard like longitude and then like transversal. Let's strive to get those perfect. All right, so I want to sketch some of the major features of a transverse wave. Now I'm going to do my best at drawing a continuous transverse wave. And let's see, so I'll go back to when Brian and I were working together. I was kind of over on this side of the room, and I was holding one end of the slinky, and then Brian was over here on this side, and he was holding the other end of the slinky. So I'm going to try and draw this like if we were looking at it from above, while the transverse continuous wave was moving through the slinky. And I think it would really just look like a sine wave, or a cosine wave, or whatever. Wow, that's I don't like that. I just have to be careful because I need to make sure that I have like an even number, an odd number of wavelengths. Let me just move Brian slightly. There, perfect. Close enough to perfect. So that's what, like if we had taken a picture from above, that's what I think the slinky would look like as the continuous wave was going through it. And I'm going to draw a dashed line. That dashed line would represent the position of the slinky if there were no energy moving through it at all. So like before Brian started disturbing the medium. So that dashed line is called the equilibrium position of our medium. And most of our wave features are discussed with reference to that equilibrium position. All right, so our first 2 features are called a crest and a trough. The crests are the positive features of the wave, and the troughs are the negative features of the wave. So we need to designate like one side of our equilibrium position as positive. I'm going to call that the side that I've shown on top. And then the other side of the equilibrium position would be the negative side. So the crests would be really not only just the positive features, but the most positive features. So like the tops that I've drawn here would be the crests, and then the bottoms, the most negative positions of the medium would be the troughs. Some years they've talked about crests and troughs in history, like about the same time we're doing this. Have you done that yet? Or maybe you're about to. Apparently, Ms. Mitchell and I have different pronunciations of some of these things. All right, so the crests are the most positive parts of the medium and the troughs are the most negative. Questions about that? We just as easily could have called down here positive and up here negative, and then we would have labeled them oppositely, right? So it's kind of arbitrary, like which side we call positive and which side we call negative. All right, the next wave feature, and I'll hurry up slightly, and in fact maybe we'll end here. The next wave feature is called the amplitude of the wave. The amplitude is like how far away from the equilibrium position can the medium get, right? So the farthest away from the equilibrium position that the medium could get would actually be at the location of our crests and troughs. So that for a transverse wave, that distance in between like the farthest positive and farthest negative and our equilibrium position, that's the amplitude of the wave. I think in some, like maybe 8th grade classes, they must talk about this differently, because every year when we have quizzes or tests and I ask for a sketch showing these wave features, every year I get at least a few people that incorrectly call this the amplitude. That's wrong. Okay, the amplitude is how far from the equilibrium position are the top and the bottom. Not how far is the top from the bottom. That's not the amplitude. That would be double the amplitude. All right, so next time we'll pick back up with our last transverse wave feature. It's 2 minutes, don't worry. We need to talk about some wave features for longitudinal waves, and then we still need to talk about speed and frequency. Do read section 14.3, though, even though we didn't finish 14.2. I do think we'll be starting, possibly finishing 14.3. The other thing that, I don't know how, but I forgot to mention, I think we said this last time though, we're going to be ready for this big quiz on chapter 10, 11, and 14. I think I said last time, like the end of next week. Most likely that would be like a week from Monday, so not the end of next week, but the beginning of the following week. Right? We're probably only going to spend like maybe 1 1/3 more periods on chapter 14. It's really quick stuff. Other questions or comments while we're kind of packing up? Yeah, Michael.
So is the homework the problem that you spoke of last time?
Well, so number 21 from chapter 11, and then problems 4 and 5 from that handout. That's what I meant to assign, and it was listed as homework on the blog entry from last class. So I'll try and tidy up my blog to reflect that that's still homework for you guys. All right, great. So let's pack up so that we're ready to go when the bell rings.